Hey everyone, this week we're talking about data science with Pyplot, and we'll do an example that could probably help with your final project. So the first example says to plot the list 1, 2, 3, 4, what happens? So we have in our code, we have some starter code, import matplotlib.pyplot as plt. So this is importing the matplotlib pyplot library, and we're also doing something called aliasing, which means we're basically just giving this a better name so we don't have to type that out every time. So PLT refers to that library. And then one other thing we want to touch on is the documentation. So I have this link. You can also just look up Pyplot Python and you should find this info. So it looks like we can generate a quick graph with plt.plot. So let's try that. We'll say plt.plot the list 1, 2, 3, 4. And this may take a moment to run just because it's generating the visualization. And let's see if there's a relationship here. So we plotted 1, 2, 3, 4, and then we said plt.show, which shows the graph. So at 0 on the x, we have 1 on the y. On 1 on the x, we have 2 on the y, and so forth. So 2 is 3, 3 is 4. Which hopefully you see the pattern by now. This list we passed into plt.plot was treated as the y-axis values. And also of note, the x-axis values start at 0. So that was sort of assumed by matplotlib. All right, so we can also, just a side note, we can also say plt.ylabel, and that will generate a y label. And we could also do the same with x. All right, so we also want to plot these two lists now. So let's comment that out and write a new plot line, plt.plot, A, B, C, D, and then we'll plot the second list, 20, 40, 80, 160, and we'll plot that. So now you can see that we've passed in two arguments to the plot function, which are two lists, and those are treated as the x values and the y values of the graph. So A corresponds to 20, B corresponds to 40, and so forth. So that's a quick intro to Pyplot, and we can see that a list, in terms of plotting a graph, typically can represent our values. All right, so example 2, again, it may be useful for visualizing something from a data set, which you'll do in your final project. So using data from Messi.csv, make a plot of how many goals Lionel Messi has scored per season. If you don't know soccer or football, this is one of the greatest players ever. And so we'll aggregate and print out how many goals he has scored over his entire career. And this data is outdated. He is still scoring goals. As with all CSVs, we know the format our data is given in. So we have season, age, squad, and then a ton of other stuff. So we're given some starter data here, import CSV, import matplotlib pyplot. So first we want to read in the CSV. And to do this, we can just say with open messi.csv as, and we'll call this CSV file. And then we can do a similar thing as we did in the files video for line in csv.reader CSV file. And if you're curious about the CSV library, you can just look at Python CSV and you'll get a good tutorial on that. But basically it just splits by commas for us, so we don't have to do that. Although we could, it just makes it nicer. So for line in CSV reader file, and then it looks like we'll actually need to store some data. So we might make a seasons list. I'll make a goals list as well, because we want to plot seasons to goals. And then sort of the part 3 of this, we want to aggregate and print out how many goals he's scored over his entire career. So I'll make a variable called total goals and set it to 0. And then we need to populate all of this data from our data file. First, we might say seasons.append, and then we need to somehow get the season out of the data. And we know the format it's given in, and CSV Reader will return a list of everything in the line. So we can say line at 0 because we know season is at position 0 when the entire line is split by a comma. We'll do the same with goals, except this time we need to hunt down where goals is in here. So we have index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we see GLS, which is goals. So goals.append line at 10. And then we want to actually remember to type convert this to an int. If you don't, weird things will happen in matplotlib because it thinks you're trying to compare strings, and so your scaling will be a little off. So we do want to type convert to an int there. And then finally, total goals should equal total goals plus the line we just got. So int line at index 10. So that's good. All of our data is collected and aggregated, and now we just need to plot it. So we can use the plt.plot function and simply pass in our lists, seasons to goals. And then we also want to label things properly. So plt.ylabel will be our goals scored, and plt.xlabel will be our season. Then we'll also remember to print out total goals. And then we'll run that. So we can see Lionel Messi goals scored versus season. Looks like our labels worked. We also did a little trick line here, plt.xticks, which just rotated the longer strings here. And we can see he scored a lot of goals in the mid 2010s. And has fallen off a little since, but still an impressive tally. Up to the point of when the data was collected, he scored 492 goals. And one more thing that we may want to do to make this visualization better, or we also could just change this, we could do a scatter plot. So we could also say plt.scatter, seasons and goals. And that would give us these nice little points as well. And without plt.plot, which just plots a line, it would look like this, although the better visualization is probably a line in this case because it shows a continuation over time. All right, that's it for our data science lecture.